Hello, today we're going to talk about polar coordinate conversions. There was a nice video that I posted about the basics of polar coordinates and plotting points on a polar grid. I wanted to highlight a couple of additional aspects of this. So what we're going to be dealing with is we're going to be dealing with our Cartesian coordinates, and that's when we choose a point in the plane and we say xy corresponds to a point that moves over x units and up y units. And we're going to be dealing with our polar coordinates. And that's when we reference a point here, not by x and y, but instead by the angle theta and the distance from the origin. And we're going to write r and theta. Now, one of the things that makes this confusing is you see two numbers in parentheses. It's hard to know, does that represent Cartesian coordinates? Does that represent polar coordinates? If you're just given one and you don't have any context, normally a good way to think about this, normally a good way to understand what's happening is if you see an angle and if you see the second number looks like 5 pi over 4, that's a good clue that you have a pair that is set in polar coordinates, because 5 pi over 4 sure looks like an angle. All right, so one of the key things that we need to be able to do is to be able to go between these two different coordinate systems. So let's say, if you're given a point that looks like x comma y in Cartesian coordinates, what do we have to do to get a point r theta in polar coordinates? Well, what we do is we use the equations that, because this is a right triangle, we know that r squared is equal to x squared plus y squared, and we know that tangent of theta is equal to y over x. And so those two equations allow us, if you're given x and y, then you know what r and theta are. So for example, let's say we're given the point 1 or negative 1, 1. That's a point in Cartesian coordinates. What does that correspond to in terms of polar coordinates? Well, what we do is we say r squared is equal to negative 1 squared plus 1 squared. So we get r squared is equal to 2. So r is equal to root 2. And when we're doing this, we'll need to take a look to make sure that we have the right r and the right theta based on the quadrant of the quadrant where the point is. All right, so we had r squared is equal to root 2, and we have that tangent of theta is equal to y over x, so 1 over negative 1, which is negative 1. And so what this means is we need to remember what some of these key trigonometric functions are for these points. So tangent of theta is equal to negative 1. That's giving us that theta is equal to negative pi over 4. So let's now put this into the plane and make sure that everything looks right. So when we're at negative 1 comma positive 1, we're up here. And so in this case, this distance, it makes sense that that's root 2. But this negative pi over 4, that's this angle. So because we want to have the angle from the positive x-axis to there, we're dealing with adding in pi. So the polar coordinates of this point are root 2 comma 3 pi over 4. But as you learned in the other video, every point in polar coordinates has multiple ways to write it. So if we wanted to use this negative pi over 4 as our angle, so we would have traveled from our point there, that's not different enough, we would have traveled negative pi over 4 angle, then from the origin, instead this direction is positive, so this would be negative root 2. So negative root 2, negative pi over 4 is another way to write this in polar coordinates. Okay, so now let's say you're given something in polar coordinates and you want to write it in xy coordinates, in the Cartesian coordinates. So that's saying if we're given r and theta, how do we get x and y? All right, and so in this case, we use the equations x equals r cosine of theta and y is equal to r sine of theta. So let's say we have polar 2 comma negative 2 pi over 3. So again, this is a clue that we are in polar coordinates because we have a pi term here. And what we're saying is that, let's draw a picture. So 2 pi over 3. That is almost negative pi. So this is 60 degrees, 120 degrees. This is negative 2 pi over 3. And then this is 2. So the question is now, what is our x and y coordinates? So we could use that this is a triangle. We could draw the triangle that corresponds to this. We have a 60 degrees here, we have 30 degrees here, and so we could draw our triangle, or we could just use our sine and cosine equations. So we have that x is going to be equal to r, which is 2, times cosine of negative 2 pi over 3, and y is equal to 2 times sine of negative 2 pi over 3. So what you're seeing here is you need to know your special values for sine and cosine as well as tangent in order to be able to do these conversions relatively easily. So maybe we should practice those. Let's just write down what the answers are. So the x value here is negative 2 times negative a half, so that's negative 1. And the y value, we have negative root 3 over 2, so this gives us negative root 3. Okay, so let's just practice our sine and cosine values because I think that's useful. So we have our 3 functions, sine of theta, cosine of theta, tangent of theta. And what I like to think about when I'm drawing my sine theta, when I'm drawing cosine of theta, is sine of theta starts off at 0, goes up, whereas cosine of theta starts at 1 and goes down. All right, and so if we were to zoom in on this first part of the sine curve, or the first part of the cosine curve, let me change the color of this. Oops. So I'm going to highlight this, make cosine green or blue. Oops, that didn't work. Highlight this and make it blue. I'll get there eventually. Change style. Done. Alright, so there's our blue function. So we have sine is going up, cosine is coming down. At our special points, which are 30 degrees or pi over 6, 45 degrees or pi over 4, and 60 degrees or pi over 3. And then we have 0, we have pi over 2. Sine and cosine always take on the same values. And I don't know if you've seen this before, but it's really, there's a nice pattern to it. So we have sine, we have cosine of theta, and we have tangent of theta. And then when theta is equal to 0, pi over 6, pi over 4, pi over 3, pi over 2, these numbers, so sine starts at 0, and it goes 1, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. So we have a really nice pattern here: square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2, which simplifies, right? It's 0, 1/2, root 2 over 2, root 3 over 2, and then 1. And cosine then does the same thing, but backwards. So 1, root 3 over 2, root 2 over 2, 1/2, 0. And so this pattern of numbers can be helpful for you. And then sine over cosine, tangent, gives us 0, 1 over root 3, 1, and then root 3, and then this is undefined at pi over 2. Because the tangent, what the tangent looks like is this. But it repeats, instead of repeating every 2 pi, it repeats every pi. So it's important to remember those functions and have them at your have them available to you. So when we're looking at cosine of negative 2 pi over 3 or sine of negative 2 pi over 3, then what we can do is we can look at where that is in our functions. We can say, all right, so this was pi, and this was 3 pi over 2. 2 pi over 3 is right here. And 2 pi over 3, so this is pi, and this is 3 pi over 2. 2 pi over 3 is right here. And so what we do is we see where we are on these paths. We see that as we're going from pi down to 3 pi over 2, we are at this version, so we get the negative 3 pi over 2. And when we are on the upswing here, we are from negative 1 going up to negative 1/2 at that point. So we're seeing that this value, cosine of negative 2 pi over 3, is negative 1/2, whereas sine of negative 2 pi over 3 is negative root 3 over 2. All right, so let's stop there for now. See you shortly.